I'm now joined with my very first live presenter, Bart Enkelaar, who's going to talk about quality of code. And Bart is also a fellow colleague of mine. Yeah, you're all colleagues, by the way, but he's like a direct colleague. I worked with him in the same IT team. So let me present to you Bart Enkelaar.
Woo! Yeah.
Yeah.
Thanks, Joel. All right.
Yeah, so you're going to talk about quality?
Yes, and we did work together for, I think, 4 years?
4 years, yeah.
Nice. Yeah.
Also in an IT team where we really paid special attention to quality of code. And
definitely, it was that team where the ideas that I'm talking about today were forged in the fire.
Will you also mention me in the presentation?
I will.
Oh, okay. Let's see how that works out. So yeah, Bart, the floor is yours.
Thank you, Joel. All right, so let's take the floor here. Okay, so suppose the slides are showing now. Hi, everyone. Welcome to the Case for Quality at Spaces Summit 2021. So what am I going to talk about today? We're talking about quality. I'll go into, this is not something that happens rarely. It's a subject that many people talk about a lot. So why is it necessary for me to talk about? Again, I'll go into that. And then I'll go into a bit of a definition. What do I understand? What do we understand as software quality? And from that, we'll derive some principles. And then we'll go into some possible solution directions, mostly about adaptable systems and relevant systems. All right. So quickly, who am I? My name is Bart Enkelaar. Joel quickly introduced me. Been here at bol.com since 2014. But before that, I was a software engineer at Topdesk. I started there at 2008. And this is where I learned the craft and also got instilled with this passion for quality. So then in 2014, I joined bol.com, where I now work as a site reliability engineer. Because I think that's one of the most vital topics to tackle well, to set bol.com up for success in the future. All right. So why this talk on quality? Why the case for quality? Why is it necessary? As I said, I've been in software engineering since 2008 professionally. And during that time, I've been to all kinds of conferences. And I must have been to DevOps at least 10 times. And at these conferences, you always see pundits and visionaries keep court on specific ways to maximize quality. And there seems to be this consensus amongst experts about what to do to build code right. And whenever I'm at these conferences, I'm like, yeah, this is the way it's supposed to be. Yeah, let's build all the software in this way. But then I get to work and I get assignments and I see code that looks like this. And I see code that makes you feel like this. I say see, but what I actually mean is I write code that makes you feel like this. And there seems to be this mismatch between the ideas that live in theory and what is applied in practice. And even what I apply often in practice. And this mismatch is why I thought, well, maybe it would be time to take my ideas on the subject and just visualize them in a way that guides me to choose quality. Yeah, because at least once a month, I still get into discussions with experienced, awesome engineers who say things like, "Let's just slow us down," which, if I look at the conferences and the blogs and the talks, is a myth that has been debunked like 20 years ago. But from their experience, from in these discussions, arguments like this arise still every day. And it makes sense, because I think there's a visibility problem that quality has. Because on this long road to the dot on the horizon, the new features are like the billboards along the road. Well, quality is maybe the little signpost that shows you the direction. But actually, quality is also the road you're traveling. It's the ground you're standing, and it even might be the horizon you're going for. So it's almost the context you need to bring these features live. But I'm getting ahead of myself. What I wanted to talk about was quality. And to do that, well, we're going to need a proper definition. So what is quality? Well, I looked it up in Merriam-Webster, and that didn't help me much because they said quality was excellence, which was the quality of being excellent, which was first class, which was of a high quality, i.e. we have a circular definition. So that didn't help me. So I looked around for other definitions, and there was this one definition I found on simplicity.com. That was that quality is fit for purpose. And this is one I like quite well. But of course, it leads to the immediate follow-up question: what is the purpose? So let's examine purpose a little bit, and then specifically the purpose of software engineering, because that's what we're all about here. So I think that the purpose of software engineering is to deliver value to the world. And as we're being fundamental about definitions here, of course, we need to look at what is value. And this, for this, I found a nice definition by the author of Understanding Software, and that is anything that helps people. And I think this is vital, because if your software does not make the life of a person easier, then it's probably not worth existing. All software should validate its existence by improving the life of someone in a way that would be better than if that software doesn't exist. So this is what I like to call axiom 1, our first definition of software quality, that the purpose of software is to deliver value. And if we look at this value, like look at a software system as a whole, how can we model this value? I look at it kind of like this. So total value of a system is the summation of all its features. And then for each feature, there's a value factor, K, times the amount of usage that factor sees. And then if you sum all those value times usages for all those features of a software system, then you kind of arrive at the total value of a software system. But so we were talking about quality and how quality is being fit for purpose. And I also looked up fit just to just to be sure. And it's not the application I worked with with Yoel on, but a good definition I found for fit is that it's ready to do this in a proper way. So that makes quality software that is optimized and ready to deliver as much value as possible. But how do you get software to become valuable? Well, that is through innovation. So, and then let's particularly look at the purpose of software innovation. And since we're all about these software systems that need to deliver value, the purpose of software innovation is to increase the value that the software delivers. So that is our second axiom, that the purpose of software innovation is to increase software value. And for this, we can say that the change in value that is hopefully positive in this sense is proportional to the amount of effort that is put into innovation on that software system. So now we have quality, and quality is that a system is ready to deliver as much value as possible, and we have innovation, which has its purpose to increase the value in the system. But there's another angle to software systems that you can't overlook when talking about the value it delivers, and that is the cost of operation of software systems. And when you look at the definition of value, where it's that we earlier specified that it's a sum of amount of features times some factor times their usage, you can make the argument that the effort that you need to put into keeping this software running, both in terms of managing its complexities, updating its dependencies, scaling its infrastructure if necessary, keeping abreast of alerts, intrusion, security. All of that scales with the amount of features and the amount of, as such, the amount of value that is in the system. So that makes this axiom free, that the amount of effort we need to put in operating our software is directly proportional to the value that a software system delivers. Now we get to a really interesting system where we have these three axioms, where we have a definition of software value, we have a definition of innovation that is to enact a change, a positive change in this software value. And we have a definition of operational effort that is directly proportional to the total amount of value in that system. And of course, this is extremely abstract and Highover. There's all kinds of things that I'm not addressing here, but these three basic rules already bring us to a really interesting conclusion, where you look at if the change in software is directly proportional to the amount of effort put into the innovation of the software, and if the amount of effort that you need to put in operation is directly proportional to the total amount of value in the system. And of course, we can only work on one thing at the same time. So the total amount of effort we have is a fixed pool where all time we spend on operation is not spent on innovation. Then we arrive at the interesting conclusion that the value growth of software system naturally reaches a horizontal asymptote. That means that as software value of a software system grows, we will innovate less and less quickly, naturally. And I think here theory lines up with what we've seen at Bot.com. When you look at the heroic efforts that were necessary to get rid of LSM, for example. Also, if you look at what's happening with POS. And Joël, this is where you're coming, because like one of the proudest moments of my software engineering career here at Bot.com was last Tuesday when Joël turned off Fit. And Fit was one of the first services to be pulled out of the LSM. And this was in a time when we at Bot.com didn't have so much experience with services. So this was built with old paradigms in an Oracle database with lots of legacy ways of approaching this software. So there was all kinds of debilitating features about this application. And why it made me so proud is that I really think that by sticking to this drive for quality as a team, by choosing to develop things in a future-proof way, we prevented a turn off the Fit Big Bang project. It was just done naturally and came to a conclusion where only 25 people were involved last Tuesday. And I think this particular instance is proof that you can work around this law of entropy of software systems, that basically all software systems are doomed. So let's look at how to approach that. How can we keep on innovating, preferably faster and faster, in a world where we're building systems that keep on being harder and harder to operate. So let's re-examine this Highover abstraction that we made for total value of a software system earlier. So we said the total value in a system is the summation of all the features that are there, and then for each feature, a value factor times the usage of that value. So very abstract, but this is just a summation of a product. So increase any of these factors and you'll increase the total value. So already this trivial equation is giving us something about what it takes to optimize for value. Because you need to either improve the amount of features, or you need to improve the relevancy of those features, or you need to improve the usage of those features. So that means that a system needs to be adaptable, it needs to be scalable, and it needs to be relevant. And regrettably, I'm not going to have the time to go into all of these things, and there's many things that you can say about these different terms, and all of them hide a world of expertise and thousands of pundits giving good advice. But there's a couple of things that I wanted to highlight about these different angles. And the first one, as I said in the introduction, is about adaptability. Because adaptability, this is where many of the main software engineering principles that pretty much everyone knows or should know are all about. You know, this is about making sure that it's easy to add new features to a software system. So this is where KISS comes into play, and this is where Solid comes into play. But to be honest, Solid is kind of outdated. So I'm really hoping for that Cupid article from Dan North to come around one of these days. But if you want to have some more information on this, you can check out the Friendly Tech Chat on YouTube, where Mikola and I discuss the problems that Dan North had with this concept. And basically, if you don't know any of these concepts, they're very Googleable. And then, of course, there shouldn't be any outstanding work in your application. If I need to add something to an application, and before I can do that, I need to fix all kinds of to-dos, fix me's, or update dependencies, then you're not having your application ready to be changed. And of course, you want proper test coverage, because all change brings risk, and you need to manage all your known risks by having automated checks. But there's much more to this angle, and what I'd like to share is the single question that I always ask myself to align efforts to optimize code for being as adaptable as possible. And that is this question: can any other engineer fix my system in half an hour? And the reason why this question is so powerful to me is that there's all kinds of interesting angles here. I mean, fixing it within half an hour, for example, means that your CI/CD pipeline definitely can't take more than 5 to 10 minutes. And that this CI/CD pipeline should go to production. But one of the critical angles here is that it's about other engineers. Because we need to think about Murphy here. Everything that can go wrong will go wrong. And that means that at some point, during a critical outage, you will not be available, which means that you need to design your systems in such a way that you don't need to be involved. And we need to talk about mental model here. And mental model is this superpower that all software engineers have, all people have, but all software engineers use to the most extent. And because it gives you the ability to reason about a system without actually going into the system. It gives you the ability to experiment on your system, all in the infinite possibilities of your head. And that gives you the capability to reason and to deduct really quickly and relevantly about the state of your system. Bob Murphy makes you not be there. So you cannot design your system in such a way that availability of the mental model that is in your head is guaranteed. So that means that your mental model should be completely backed up in your code, and the documentation around your code. It can be README, contributing, change logs, documentation, tests for a very large part. Because in order to fix your system, someone needs to understand your system. That means that everything that is relevant to understand your system needs to be in the code to be communicated. And that is really what the hardest part of coding is. Getting the computer to understand it is easy, but getting other people to understand your code, that's so much harder. And this is where the mental model is not just a superpower, but it also blinds us, because it becomes so natural to us that it blinds you from the fact that others do not have your mental model. And this is why things like code reviews are so important, even if you've pair programmed on features, because as you're pair programming, then you're aligning your mental models together, which means that what you're building is based on a process and not on what is there. So even if you're pair programming, it also always gets someone else to review it. And this is also why I hate with a fiery passion packages like this. No, it's easy, but it tells me absolutely nothing about what the system does. So if this is your package structure, maybe see if you can change it to something that actually helps someone who does not know your system find what they need to find. Right, and one more thing about mental model. Having this mental model backed up in your code is, let's go here. It also helps you yourself, because as software engineers, we're not working on a single application. I think average teams these days have like 5, 6 different applications they're working on, which means that they need to context switch between different applications. And if you need to keep all those mental models parallel to each other in your head, that means by necessity that a part of your faculty is not focused on the problems you're solving now. Those faculties are focused on the problems, on keeping those mental models in line of all those other things. Well, if you have your complete mental model backed up properly in your code, then you can just recover from backup whenever you want, and you can delete it whenever you want to work on something else. And I'm talking like it's a disaster recovery operation here. And I think like recovery time objective and recovery point objective, those things are actually just as relevant here. So that's why I like thinking about it this way. Right. So the other thing I wanted to discuss about the factors that make a quality software engineer is software system is this third angle here. Building relevant products. How do you features? How do you build features that maximize the value per feature? And the chaos report of 2015, I think, but it hasn't changed much since, says that 66% of software projects fail to deliver the right functionality in time. And of course, there's a large agility angle here. But I think what we are particularly not doing enough at Bol.com is setting features up to fail. And I think there's several talks today at Spaces Summit. I saw Anastasia's proof of concept talk. Go check that out because she has excellent pragmatic tips for doing proof of concepts. Because I'm kind of skipping ahead here, because we live in a volatile, uncertain, complex, and ambiguous world, which means that we can never know which features will deliver the quality. And if we do with all features, what I said before, if we build all features in such a way that you're completely paying forward the effort you need to take to make them easy to extend, because you want to limit the rate at which that what's it called, that point of doom that of software systems approaches. You want to limit that range. Right. Let's go back to where I was starting, because I'm losing my train of thought here. We live in a VUCA world, and that means that you can never know which features will deliver the right value. So what you need to do is you need to be able to test your features out before you invest heavily into these features. And a good way to do that is Canbax 3x model. Right. Yes. In this VUCA world, we need the organizations that become the most successful are the organizations that set themselves up to learn as much as possible, as quickly as possible. And this is which means that bringing a feature to a place where you can learn from it needs to be optimized for rapid testing, for rapid experimentation, I must say, in production. But bringing a feature to a place where it becomes part of your system to be able to build on it and go forward, that is a whole different set of requirements. And that is where Canbax 3x model comes in. That you need to have a phase where you explore, then you expand, and then you extract. So in this exploration phase, what you do is you build experimental features. And here you do not optimize these for the other factors, because let's think about what we're doing here. In that summation over features of value factor times usage of the value factor, we're now trying to get K as high as possible. But what we talked about before, adaptability, is about making it as easy as possible to add more features into it. So what you need to do is you need to have one pipeline for experimenting with features to test their K as quickly as possible. And you need to have an entirely separate pipeline for taking features of which you've proven the value and building them in such a way that you can build easily on top of them. So this explicit difference between experimental features and expanded features, and then taking the determined effort to expand features before you build on top of them. This is something that I think we do way too little at Bol.com. And I think you can do this everywhere. You can do this in code bases by making sure that you have separate packages which you don't let any experimental features build upon. So you build all your experimental features based on your high quality expanded features. And then in your experimental features, you can duplicate, you can set it live, you can bring it down. I mean, feature flags are a great way to test these things quickly. And then, you know, because these are in a separate package, that you cannot, or maybe even module, you cannot use these for your continuing expansion. And before you get something from the experimental package to your expanded package, then you have extra effort, because you have a new way of designing, a new concept for these features. That means that you need to redesign the way you build it. Right. Okay. So let's go over what we talked about. So we started from the very beginning with this mismatch between the theory of quality that we've seen at conferences and a daily implementation in discussions and code bases all over the place. And we've discussed briefly of why that might be. And then we arrive to the interesting conclusion that all software is doomed. So yay us, we're all gonna die. Which is true, but it doesn't mean that it's pointless to innovate. It means that we need to innovate in such a way that we balance the curve of this decreasing returns with new innovations and new innovations coming outside of bol.com. And two ways to stave off the inevitable that we've discussed are build adaptability into your systems by using all the well-known and available software engineering tools to build quality code, and build the right things by making a hard cut between experimenting and expanding and building a system for the long term. And then there is, of course, all kinds of other approaches to take. But I think these are two steps are a great way to start. And then we can hold off the horizon of doom together. So that was my talk. I'm curious to see if there's any questions. Joël.
Yeah, thanks, Bart. Yeah, very like I said, we work together in a team, and so I very much agree with all the things you've said. Actually, some input has come in, but it's all statements, it's not questions.
Okay.
So
let's see about this.
So the real first statement.
Yeah.
It's about the quote you mentioned. Do not let perfect be the enemy of good. The person who posted this statement said, really like that one. It describes an attitude and state of mind that we could really benefit from more.
Yeah, definitely. So do not let perfect be the enemy of good. And I think this difference between experimenting and expanding comes into play here, because well, I think what was said is actually really good.
Yeah.
Never mind.
No. Yeah, sorry, it's just a statement. So
no, it works.
You don't have to answer actually.
Yeah. Okay.
And there's another statement. So also no answer. No.
Okay. Someone's on fire.
Yeah, or maybe someone else.
Yeah.
Or it's actually a suggestion. Read Zen and the Art of Motorcycle Maintenance for good pondering of what quality is. It's undefinable but clearly visible to anyone who cares.
Right, and that I heard about the book, and I haven't read it, but I will. Okay. And that angle of caring for your code base, that is a really good one, and because it's interesting. It is indeed ungraspable, but it's always so clear. I have this very much with interviews I do with candidates, that if a candidate genuinely cared for the code they delivered, it immediately shows. And it's always a big plus for a candidate if they show that. You can, to me, it always comes screaming off the screen when someone's really put their heart and soul into optimizing this code for, yes, this is the way it should be. Yeah. Like every character is at the place where it needs to be. And that touches me.
Yeah, what I also very much liked about the talk is like the mental model, because also when I write code, it's I'm sometimes also thinking like, okay, if I write this down, is the future me, like in a year, is he going to understand what's going to be able to understand this in like 5 minutes what's happening here?
Yeah, exactly.
And also with code reviews, if I see code from my peers, and I like within 10 minutes. I don't understand it, then something's wrong.
Exactly. Yeah, and this is also interesting about how you don't need to be more senior to review code, because it's not about showing how it's done. It's about understanding it from a completely different angle. So, and I even think that it's also possible for people who are more junior to interview candidates that are more senior, for example, because explaining code, it's so much about making the connection between different people and bringing this infinite cloud of possibilities from my head to your head. And that is such an interesting human challenge that it really doesn't matter how much experience you have.
Yeah. And also where I see it is in the SRE or the SOD world.
Yes.
Because I'm also an SOD and you are too.
Yeah.
And also there we take the responsibility to manage services out of office hours. But we really need to be really quick in understanding the mental model of some application, because it could be that we never have seen it before, and so there goes an alert at 2 a.m. and we should like be really fast to understand what's happening and how the stuff is working.
Yeah,
so we can decide what to do and what the impact is if something fails. So there's really.
Yeah, and 2 a.m. is weird. It's like I wake up and I can't even do proper maths, right? Like it's like it's now 2 o'clock, so I have 3 more hours until 8 o'clock. It's like what?
I'm sure there's a trade-off between like doing a rapid prototype and but I think you describe it really well in the exploring phase, and where there I think it would be fine. If you do rapid prototyping and just have ugly code, but at some point when you can expand, you really need to make sure that you have that adaptability in your system, in your code base, in your runbooks, right? And to also document.
Yeah, exactly, definitely. And Anastasia said this in her talk, that there's always pressure to go on. So once it's there, just go on to the next thing. But this is why this hard cut between your experimental features and your stable features is so important. Like experiment completed is not done. So there is no option of going on because it's not live yet.
Yeah.
So that's something I think we really should internalize as a company.
Yeah. Yeah, cool. Oh wow, there's a lot of. I think we have initiated some other people.
Excellent.
Yeah, we have some time, so let's just take it. Do you also test critical non-functionals in experimenting, or do you leave that for later? Or do you leave it for later, in your opinion?
Good question. So then you're talking about performance, and so this is where the scalability angle of features comes into play. And I would say it depends. Of course, it's like very software engineering answer, but because non-functional is an extreme misnomer. Because usually, if say for example, if an endpoint is too slow, it will the consuming service or person will just refresh or cancel it, and that means it's not functional. So actually, that it's fast enough is actually part of your functionality. So if that's the case, then proving that it's fast enough should be part of your experimental phase.
Okay. And one question from out here, there's a name also there, Natalia Paratsikidou.
Yeah.
If you build your innovation in complete isolation from the expandable application, and as you mentioned it, takes a complete different design turn, how do you merge the two? So I think what she means is if you like, oh wow, more popping up. If you if your innovation is like separate from your existing application. So you can do your experimentation, it can fail, and
right,
and then later on you want to merge the two.
Right. Okay. Yeah. So I don't think you should merge the two.
Okay.
I think it's a really good idea to do a proof of concept that's entirely separate from your like expanded application. But then what happens when you make that new feature part of your expanded application is that the context of everything that is in your currently expanded application changes, because now it's not the sum of the features that are here. Now it's the sum of all the features, which means that incorporating these new proven valuable features into the whole set of features means effectively a redesign of the whole application. I mean, I make it larger, but this is where not doing premature generalizations comes up. Like if you were to have built this experimentation immediately into the application, maybe what you would have done is introduce an abstraction above it, because now we have two. But then if it turns out that this feature doesn't happen, is not valuable, then now you have an abstraction here that is not optimized for the feature here. So you need to build these higher abstractions when you are integrating it. So designing for an expanded feature is a different design than designing for an experimental feature. And therefore, a merge is not the right way to go about it.
Yeah, so you should just leave it separate. If it's possible to be separate in the first place, just leave it separate.
Yeah, definitely.
What's your take on the mentality of move fast, break things that has worked for some players in the market, but is really sacrifices quality sometimes?
Yeah, so I think breaking things is a fantastic way to learn. But this is all about experimenting on production. And I think that mentality is really important if it's built upon a groundwork of quality. And I think I'm falling on repeat here, but that hard deadline between breaking things and making things, of experimenting and proving value and building to enhance value in the future, that is key.
Yeah.
So they go hand in hand, but they need to have solid feet on the ground.
And then the question is, where do you transition? Where's the point where some experimental feature becomes part of the expandable existing application, and where do you have to make the switch from, like, how was it said here, move fast, break things, to like
I think one clear way to transition is if you want to build something that needs that feature, because I think you should never build anything that builds upon another experimental feature. So
sure.
That is a clear point. And the other deadline for me is 2 weeks.
Yeah.
If something lives longer than 2 weeks, it needs to be built properly.
Yeah. Cool. And there's another one. Do we only have to care about adaptability after we experiment it, or shouldn't it be that strict? Since having the mindset already during experimenting could save time later. How is it balanced?
Yeah, of course, the areas are gray because the world is interesting.
It depends, right?
Yeah, exactly. But I don't think building everything as expanded features yet saves time, which I think is what the question is suggesting, right? However, there will be features where you know upfront that, like, for example, we're building BFC2. This is a big project that will be built.
Yeah.
So
there's deadline
features for BFC2. I mean, there's construction workers laying the groundwork. Anything that you build an application to support that BFC2 will live a long time. So there you don't need to bother about experimenting with those features.
So the quality should have high priority in the first place, because you know it's going to live for.
There is no option to experiment there, because there is a pipeline of dependencies that need to build upon it, and therefore you need to support it, and therefore it needs to be quality driven.
Yeah.
So there are certainly features that you can develop without experimentation, but you can never say all features are worth building quality first, always.
Yeah. Yeah, cool. Yeah, when we first talked before the presentation, you were wondering if it wouldn't be too vague, but for me it made a lot of sense, and especially because it's resonating so much with the mindset that you should have about quality of code and being adaptable, and yeah. So thanks for the talk.
Cool. Thanks for having me. It was as I said yesterday, it's always a great fun being back at the office for a bit. And good luck with the rest of the Spaces Summit. And everyone who's watching, I'm hoping you're having an excellent day. And I hope to see you all at the pub quiz, I guess.
Yeah. Hey guys,